Hello everyone, and welcome to my channel. This channel is all about turning you on to new and exciting, or old and exciting, theories of everything, cosmologies, all-encompassing theories, paradigm shifters, magnum opuses from obscure authors, and tour de force writings from people you might not have heard of. And today is our 401st video on the reciprocal system of theory. And this theory was developed by Dewey B. Larson back in the 20th century. In 1959, he put out his two fundamental postulates, boiling down the nature of his universe, and that he basically induced through long period of study. And then he took his two fundamental postulates and put them through a process of deduction. If this, then that kind of process, 165 steps that I've outlined in 15 videos that are called the outline of the deductive development of the reciprocal system. That I did about a year ago. So if you want to go back, and you can refer to those. And he eventually, through this process of deduction, arrived at a theoretical universe. Basically, how his universe would look if his postulates were correct. And lo and behold, his universe looks quite a bit like the actual, so-called actual universe that the modern legacy scientists have measured and compiled in their laboratories and observatories, and have compiled into their tables and, scientific reference works. In his books, Larson compares his predicted properties with the properties that the scientists had already, written up. So when I saw that Larson was able to deliver the goods like that, I figured either he's a complete fraud or he's really onto something. And so I started checking into his writing, and I suppose he could be a complete fraud. But if you pay attention to what he says and the way he writes, the way he speaks, and also what did he gain from all of that? His whole work amounts to a statement against interest, which is a legal, a legal doctrine that basically says if you're testifying to something and it is not in your favor, then you're more likely to be telling the truth. And so, Larson doesn't really have a motive to be lying or fraudulent about it, because he didn't make any money and he never got any fame. And, maybe his motive was, oh, well, if I defraud you now, in 100 years, I'm going to be famous, after I die, maybe, But we're actually going over a talk that he gave back in 1968 called Around Unexpected Corners. And Mr. Larson, we started this paper yesterday. So we're going to be getting into more of the paper here today. And he's going to kind of be going over the reciprocal assumption. And just to give you really Larson's first postulate, where he lays out most of this reciprocal assumption, and the first postulate is where he does the lion's share of the work here, is that the universe is composed of one component, entirely of one component, motion, existing in 3 dimensions in discrete units, and with 2 reciprocal aspects, space and time. Okay, so that's basically where you're getting this reciprocal system. The universe is made out not out of matter, not out of energy, not out of force, but out of motion. Motion is the relationship between space and time, which sets up a generalized reciprocal relationship between space and time. Motion is basically a fraction, with space or time as the numerator and time or space as the denominator. Space and time behave like reciprocals in that they have identical qualities, except that they are in reverse order. And they do not exist in and of themselves. They only exist together in motion. And, he goes from there. But I think we're just going to try to get started here. And I think he might flesh out a few more of the finer points of the reciprocal system as we move along in this paper. I think I try to go back half a paragraph or something. Okay, so I began to take a critical look at the reciprocal concept between space and time. And as soon as I did so, it was immediately apparent that this idea was not so absurd after all, since there is definitely a reciprocal relation between space and time in the only physical phenomenon in which we can recognize a direct association between the two, the phenomenon of motion. In motion, more space is the equivalent of less time, and vice versa. It makes no difference whether we travel twice as far in the same time or whether we travel the same distance in half the time. The effect on the speed, the scalar measure of the motion, is exactly the same in both cases. Then, too, it was also evident that this reciprocal assumption was opening the doors to some new and logical answers for long-standing problems in physical science. One of these, a very important one, is the problem of gravitation. Here is one of the foundation stones of physical science. In the words of Paul Arheil, one of our leading investigators of the subject, quote, "The more we study gravitation, the more there grows upon us the feeling that there is something peculiarly fundamental about this phenomenon to a degree that is unequaled among other natural phenomena." End quote. Actually, we do not know very much about it, aside from some information about a mathematical nature, such as the inverse square relation, the relation of the force to the masses involved, and the value of the gravitational constant. But all we know from observation is that gravitation acts instantaneously without an intervening medium, and in such a manner that its effects cannot be screened off or modified in any way. The point that impressed me most forcibly at the very beginning of my application of the reciprocal assumption to the gravitational problem was that this assumption led directly to a theoretical situation in which gravitation acts instantaneously without an intervening medium and in such a way that its effects cannot be screened off or modified in any way. Perhaps this may not strike you as anything particularly significant. Your reaction may be, so what? Doesn't any theory have to agree with the observed facts in order to be considered valid? And I would have to concede that as a general proposition, that is true. But the significant point in this case is that no previous theory has agreed with the observed facts. And what is even more significant, present-day theorists are so convinced of the impossibility of ever formulating a theory that will agree with these facts that they have adopted the unprecedented policy of constructing a set of fictitious facts with which they are able to show agreement, and substituting these fictitious facts for the facts of observation. Even though there is not the slightest evidence that gravitation is propagated at a finite velocity, present-day theorists have made this the cornerstone of their gravitational theories. It is not even claimed that this assumption is supported by any facts. Max von Laue, for instance, makes this very frank admission, quote, "Nowadays we are also convinced that gravitation progresses with the speed of light. This conviction, however, does not stem from a new experiment or a new observation. It is a result solely of the theory of relativity," end quote. Then, since such a propagation requires a medium, the theorists have had to assume the existence of a medium, even though here, again, there is not the least bit of evidence in support of such an assumption. It is commonly stated in the textbooks that Einstein's theories eliminated the need for a medium and consigned the ether of the 19th century to oblivion. But this is a misinterpretation of the facts. Einstein's accomplishment in this area was merely a bit of scientific legerdemain. R.H. Dick, one of our present-day gravitational experts, calls it a, quote, semantic trick, end quote. But before Einstein, science had two concepts in this area. One which was called space, and the other that was called the ether. What Einstein did was to eliminate the concept space and the name ether, so that what current physical theory now has is the concept formerly known as the ether, but it is now called space. Einstein himself cannot be charged with misrepresentation, as he freely admits that his space is actually an ether. Quote, "According to the general theory of relativity," he says, "space is endowed with physical qualities. In this sense, therefore, there exists an ether," end quote. Just how it is possible for an intangible entity such as space to have these physical qualities is a subject on which he is very vague. In his words, quote, "Our only way out seems to be to take it for granted that space has the physical property of transmitting electromagnetic waves and not to bother too much about the meaning of this statement," end quote. The most striking result of the application of the reciprocal assumption to the gravitational phenomenon is that it produces a totally new explanation of a logical and rational character in an area where scientists have long been convinced that they have examined all possibilities and that no genuinely new explanation is possible. It is asserted over and over again in the scientific literature that there are only two options. Either gravitation involves action at a distance, a concept that is generally rejected by scientists, or else it must be propagated at a finite velocity. We are told that any other alternative is logically impossible. But notwithstanding this dictum, another rational alternative does appear as soon as we start to examine the consequences of the reciprocal assumption. This is no isolated case. Time and time again, during the development of the new system of theory, completely new answers have been obtained in areas where present-day science claims to have examined all conceivable alternatives. There is no other way, Einstein tells us in speaking of his assumption as to the contraction of space. But there is another way. And just as soon as this other way emerged from the investigation that I am now discussing, all contentions that it did not exist were immediately and totally demolished. This is not a matter of opinion or judgment. Just as soon as another alternative to anything is produced, all assertions that there is no such alternative fall by their own weight. It is clear from the many results of this kind that I have obtained that the human race has not yet reached the point where it is ever safe to assume that all possible alternatives have been examined. We may be wise, as we are claiming when we apply the name Homo sapiens to our species, but we are not yet omniscient. Regardless of any other merits that it may have, the investigation on which I have been engaged has been has made a very definite contribution to science by puncturing the claims of those who attribute finality to the current scientific opinions and theories. This has a particular significance for those of you who are just beginning your life's work, because it means that regardless of all contentions to the contrary, no doors are closed to you. You do not have to listen to those who say that their ill-contrived and unproductive ideas must be accepted because there is no other way. You do not have to be content with theories that are, quote, conceptually imperfect, riddled with inconsistencies, or full of intolerable paradoxes, all of which are descriptions that have been applied to some of the most cherished products of modern science by prominent members of the scientific profession. You do not have to accept the statements of those who presumptuously assert that they have already examined all conceivable alternatives. Not only in science, but in all fields of human activity, you are at liberty to reach for the stars and to reject the counsel of those who insist that you must be limited by the failure of your predecessors. There are some other limits, it is true. You cannot get something for nothing. You cannot have your cake and eat it too, and so on. But wherever there are genuine problems, there are also answers, and those answers can be found if you will look for them without fixed presuppositions and prejudices. At the stage of my investigation, when I had completed my initial consideration of the most immediate consequences of the reciprocal assumption, some of these long-sought answers were beginning to appear over the horizon, and it was therefore clear that I had no option but to continue with my investigation, even though the task ahead was now vastly greater than anything that I had in mind initially. This is a good example of what I was talking about earlier when I said that the investigation got out of hand, so to speak. You will note that at this point, the sheer force of circumstances generated by the project itself simply forced me into a path that I previously had no intention of taking, and gave me a momentum toward a goal that had no place at all in my original plans. The first problem with which I was confronted at the start of this new phase of my project was the necessity of making a decision as to the course of procedure to be followed. After considering various possibilities, I concluded that it would be advisable to see how far I could go in constructing a purely deductive system, starting with a minimum number of assumptions and developing the consequences of these assumptions step by step without introducing anything from outside the system. The construction of a theory of this kind, comprehensive enough to cover the physical universe as a whole, has always been the dream of science. And since the philosophy that I've just been expounding to you tells us that we should aim high, I decided that I should at least make the attempt. Just what constitutes a minimum number of assumptions is not self-evident, but a review of those phenomena to which the reciprocal assumption appeared to be most directly applicable, particularly electromagnetic radiation and the recession of the galaxies, indicated that the only physical assumptions, in addition to the reciprocal relation that would be required to define these phenomena, were that space and time are three-dimensional and that they exist only in discrete units. On the mathematical side, extrapolation of experience led to the assumption that space and time conform to the relations of ordinary commutative mathematics, that their magnitudes are absolute, and that their geometry is Euclidean. For those of you who don't know, I didn't look at Larson's second postulate. He has two fundamental postulates, and I earlier announced his first one, but his second one is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute and its geometry is Euclidean. Just what he said in this last sentence. So, and in the sentence before, he's referring to the first postulate. So he's saying here, in addition to the reciprocal relation that would be required to define these phenomena, particularly electromagnetic radiation and recession of the galaxies, were that space and time are three-dimensional and that they exist only in discrete units. Okay, that is the first postulate. And then on the mathematical side, extrapolation of experience led to the assumptions that space and time conform to the relations of ordinary commutative mathematics, that their magnitudes are absolute and that their geometry is Euclidean. A lot of Larson's followers have somewhat rejected that second postulate for being not inclusive enough, and in particular replaced the Euclidean geometry with projective geometry, which includes Euclidean geometry. So they're not saying that he's wrong, but that he's not inclusive enough. He's referring to a specific set of circumstances where he's talking about this electromagnetic radiation and this recession of the distant galaxies that may not obtain in all physical situations. And so projective geometry gives more coverage, particularly when you're outside of the gravitational limit, such that, the distant galaxies are moving outward at the speed of light or greater, such things like that. Not terribly relevant to, the purposes of reading this. So we'll move on. What I had in mind in starting the development with nothing but motion, that is actually the name of the book of his, mainly on atomic physics. It's one of the first books, the first of three of his Structure of the Physical Universe trilogy. What I had in mind is starting with a development with nothing but motion and its two aspects, space and time, and with only these 6 assumptions as to the properties of these entities, was that I could go as far as I could on this basis, and then when something else was needed in order to continue the development, I would introduce additional assumptions accordingly, keeping the number of these assumptions always at the bare minimum. It seemed rather obvious, for one thing, that I would not get very far before it would be necessary to assume the existence of matter. But much to my surprise, when I examined the different kinds of motion that could exist on the basis of the original set of original 6 assumptions, I found that one of these, simple rotational motion, would necessarily exist in the form of individual units, of such a nature that we can readily identify them as atoms. That these atoms would behave as if they were exerting mutual forces of attraction upon each other, a phenomenon that we can identify as gravitation. That the addition of successive units of motion to the different dimensions of the atomic rotation would take place in a definite sequence, resulting in the formation of a regular series of combinations that we can identify as the chemical elements, and so on. Thus, both the existence and the characteristics of matter were consequences of the 6 assumptions already made, and it was not necessary to assume the existence of matter independently. Since I now had both matter and motion to build with, the question naturally arose, is anything else of a basic nature actually necessary? 20 years of additional work answered this question in the negative. The only additional assumption that I found it necessary to make is the assumption that no more assumptions are required. That is, the assumption that space-time, or motion, whichever you prefer to call it, is the sole constituent of the physical universe. For convenience, I have combined this new assumption and the original 6 into 2 postulates, one as to the physical nature of space and time, and the other as to the mathematical behavior. The new physical theory that I am discussing this evening in a purely theoretical structure derived from these 2 postulates, and only these 2 postulates, without introducing anything from observation or from any other outside source. The mere existence of space and time with the postulated properties has certain primary consequences. Interaction of these primary consequences with each other and with the postulates then results in a large number and variety of secondary consequences, which in turn give rise to still further consequences, and so on until a whole theoretical universe has been derived, or has been defined. For the next 2 or 3 minutes, I'm going to be saying some things that might give you the impression that I have interrupted my talk for a commercial. But my only excuse for taking up your time at all is that I believe it would be distinctly to your advantage to become familiar with these new developments, and I have now arrived at the point where I should give you some specific reasons why this is true. The fact that this new theoretical system derives from conclusions applicable in all subdivisions of physical science from the same premises means that we now have, for the first time, something that can legitimately be called a theory of the physical universe. Few previous theories are applicable to more than one of these subdivisions, and none is applicable to many of them. No previous theory, for instance, can produce a logical explanation of the recession of the galaxies, and of gravitation, and of the basic structure of matter, and of the nature of electromagnetic radiation. But all of these are merely the immediate and direct consequences of the basic postulates of the new system, just the beginning of the vast amount of information that can be derived by a more complete development of these consequences. The comprehensive nature of the new theoretical system is the first of its distinctive characteristics that I want to emphasize. But the same thing that makes it a complete theory, the fact that it derives conclusions applicable to all subdivisions of physical science from the same premises, also makes it possible to demonstrate that it is a correct theory and that the theoretical universe derived from it is a true and accurate representation of the actual physical universe. The best way of explaining how such a proof of the validity of the system can be accomplished is to compare the construction of a theory to the preparation of a map. Both maps and theories are often wrong, and they must be checked for accuracy before we can have full confidence in them. But the process by which the map or theory was produced has an important bearing on the nature of the tests that we apply and on the kind of conclusions that we are able to draw from the tests. In the case of a product of the traditional map-making or theory construction process, there is no option but to check each feature on the map or theory individually, because with relatively few exceptions, verification of any one feature does not guarantee the accuracy of any other feature. Verification of the position shown for a river in one part of the map does not assure us that the position shown for a mountain in some other part of the map is correct. On the other hand, if a map or theory is prepared in one operation by a single process, as is true when the map is the result of aerial photography, and as is also true where all of the conclusions of a theory are derived from a single set of premises, the nature of the test is quite different. It is still necessary to compare some of the features of the map or the theory with information that has been derived from other sources, but in this case, the verification of the individual features is merely incidental. The important point is that each such check is a test of the accuracy of the process. Even if one feature of the map or theory is found to be in conflict with positively established facts derived from other sources, then the process is inaccurate and the map or theory as a whole is unreliable. But if no such discrepancy is found in the initial examination, then every additional check that is made without finding any discrepancy reduces the mathematical probability that any discrepancy exists anywhere in the map or theory. By making a sufficiently large number and variety of such checks, the probability of any error can be reduced to the point where it is negligible. Okay, we're going to leave it off right there and start up this paper tomorrow again. So I hope you got some inspiration from this. Larson's encouraging us to shoot for the stars. And to recognize that just because the scientists say that some conclusion, some solution is impossible to find, that just means that they haven't found it. Doesn't mean that it's impossible. And in fact, it means that it actually is there, but they just have overlooked it. Okay, thanks for tuning in, and have a great